Right. I'll just say it's really good to be back here. I did my degree at Manchester University, and the 3 years I spent here in the 90s, the weather never did this. It never looked like this the whole time I was here. Anyway, yeah, no, it's very, very cool to see how much it's all changed. Yeah, so as per the intro, I'm Greg, co-founder and CTO at Undo. I'm going to talk about intermittent test failures and how you can deploy what we call software flight recording to allow you to fix even the most difficult intermittent failures. And I'm also going to talk about why that's so important. And perhaps more important than, I mean, it's clearly important, but maybe it's even more important than than is obvious. So to start with, we're going to look at Austin Powers, good old Austin Powers, right? And if you remember from the film, he's put to sleep in the 1960s, he's woken up in the 1990s, and everything has changed, right? And he's completely all at sea. He's got no cultural reference points. Everything is very different. Now, I think if you put a programmer to sleep in, say, 1990 or mid-90s, and woke them up 10 years later, I think they'd be all right, actually. I don't think they'd have a very Austin Powers experience. This is Visual Studio from 1993. This is the way programming looked and was done back then. 10 years, 15 years later, okay, it's like there's more pixels, it's a bit prettier, but everything is basically the same. And software development is done fundamentally in the same way. So I think you could be asleep for 15 years, come back, and you'd be straight back in the saddle, no problem at all. I think if you put a programmer asleep about 10 years ago and woke them up now, then they would have the full Austin Powers experience, right? Everything has changed. We've moved to a world where everybody's standing in front of whiteboards with post-it notes over them. Everyone's doing this agile thing. People are doing test-driven development. There's far more testing going on. Everyone's doing at least automated testing, if not full continuous integration, if not full continuous deployment, right? And this would be, this definitely would blow the mind of somebody who'd been asleep for the last 10, 15 years. The idea that we're just going to push code to the repository and then it's going to be out live. And we're going to do that testing in production. What kind of crazy idea is that, right? But actually it's really powerful, as we know, right? And I think now, not everybody can do continuous deployment. There are sometimes regulatory constraints that mean you can't do it, or maybe it's just not appropriate for where you are. But I suspect most people, and especially people here today, are doing at least continuous integration and probably most of that flow. So what we mean, just to clarify, by continuous deployment, the tests are okay, everything just deploys straight away, right? But what does tests are okay mean? Does it mean you have 100% test coverage of your code? Well, almost certainly not. Tests never are sufficient to know everything is good. But does it mean you have 100% reliable test suite? Well, you'd better, right? If you have flakiness in your test suite, then the whole kind of continuous, the CI/CD pipeline premise is shot, right? Because you can't tell, the machine can't know whether the tests are good. It needs human intervention to look at those flaky failures and see what's good and what isn't. But even as, and I suspect most people aren't doing the full CD thing, because as I say, if you're lucky enough to be in an environment where you can do that, then it's great. But most of us have external constraints that mean that's not practical. But I think that the continuous deployment bit, actually, I think it's useful because it's got quite a shock factor. It makes you think. But I think it's actually not, it's really just the icing on the cake. It's not the bulk of the value in this new continuous integration, agile way that we work. And I think if you go back to days of yore, we all kind of everyone just accepted that there was this trade-off between productivity and quality. So if you're writing games, you're churning it out, you've got to get the thing out for Christmas, and if there's a few bugs, so be it, right? If you're writing flight control software in an airliner, not so much, right? And that sort of safety critical code, you can't even measure how many lines per day a developer is producing on average, because you can, but it's less than one, right? Very, very high quality, but extremely low productivity. But what we've discovered through the new way that we do, and particularly around the new way that we do testing and that whole software development lifecycle, is that that's not true, right? You don't have to, back when you had to choose between these things, you choose between productivity and quality. Now, of course, there always were lots of things down here which had lousy productivity and lousy quality. That was quite easy to do, but it was sort of accepted that you've got to choose between one or the other. But it's not true, right? And we've realized that over the last sort of 5-10 years, that if you do the full, if you do develop differently, quality and productivity can become enablers for each other. They become kind of symbiotic. In fact, you can't really have high productivity without having very high quality. Right? Nothing less productive than if you make some change, test starts failing. Well, is that failing test due to the change that was made, or is it just because, like, it's a Tuesday and it fails sometimes on Tuesdays? Right? That's a very unproductive place to be if you're not building on those solid foundations. But this has implications, right? Well, first, in that old world, it wasn't uncommon for there to be no automated testing at all. I mean, when I first started working, it's kind of shocking to think about, but it was really quite common. In fact, I still know it's probably more common than you might hope today. I've heard some pretty bad stories of where test scripts mean like Word documents that somebody goes and types what it says to type in the script, and then you see whether it worked or not. And it's all very manual, very ad hoc. 50 tests would be quite an extensive test suite in such a world. And maybe you'd run it once a week. I mean, this is 15 years ago, this was by far from the worst, right? Much better than the worst case. And what does that mean in terms of how reliable you need your test suite to be? Well, let's just do some random numbers, right? So let's say half of those 50 tests are completely solid. They always pass. I mean, obviously the code they're testing might cause the test to fail, but the test itself never fails, right? A failure of the test definitely means a failure of the code. And let's say the other half are like 99% reliable. So this is still pretty good, right? Again, it's not hard to find things that are much worse than that. And that would work, right? So if we just do a quick little bit of arithmetic, we can see, well, okay, so 25 of the 50 tests are going to fail, one run in 100. So you're doing that every week. So roughly once a month, you're going to get one of the tests itself fails. That's kind of livable with. In the modern world, we've got continuous integration, and you've got elastic compute resource in the cloud, and you're testing kind of cross products of all these different combinations. 50,000 tests is not a big number, right? And if you're triggering those tests of continuous integration every time some code is pushed, running it every hour is not a big number. And that's actually, I picked those numbers because that's pretty much what we do at Undo. And it's quite reasonable from an AWS build point of view. It's very easy to do that. Let's say that we've got the same failure rate. So half of our tests are completely solid, and the other half fail 1% of the time. So that's 250 failures out of every run that we're doing, right? Every day, every hour. If you're doing that continuous integration style, you're doing it all the time, every hour, every day, every week of the month. Now we've got 182,000 failures of the test suite, which clearly you can't diagnose that, right? So that's clearly not going to work. So let's take some numbers that are much, much better. Let's say we've still got our 50,000 tests per hour, and 99% of them are completely solid, right? And of the other 1%, they're 99.9% good, right? So we're getting one failure in 1,000 of just 1% of our tests. Everything else is solid. That is a high bar. That is difficult to achieve, right? You start to get into, almost into like cosmic rays can cause quantum effects on your CPU or something, and this is a really, really reliable test suite. Still, you do that little bit of arithmetic, and we're getting those numbers. 50,000 times 0.01 times 0.001 is 0.5. Right? So half of your test runs are going to fail due to the test run itself is going to fail, right? Or 168 hours in the week, so that's 84 failures per week, or if we're doing it the old way, for consistency through it. So that's still quite a lot, right? Even that incredible reliability of your test suite at that kind of testing level it needs to be better than that. If you can do it, if you can go green, stay green, right? Get your CI to be consistently green, and any red in any failures are failures of the things that are being tested, then the productivity and quality game is like, it's so valuable. The payback is huge. But the investment is significant. It's really hard to get there. And it's actually not that hard to stay there, right? You get the broken windows theory stuff comes into effect, right? Well, if you've got flakiness in the test suite, then it's really hard to know whether you're introducing new flakiness or not, right? And you get in, and I saw this at Undo a while ago. We had a test suite that was probably roughly at those for our own code, a test suite that was roughly those numbers I just mentioned. And so half the time the test suite would fail, and people, they're under pressure to get things done, and people would just up arrow run it again, see if that's just flakiness, because I don't trust the test suite. Oh yeah, good, it passed. Now, how do you know whether you just got unlucky the first time and now that flakiness and you're all good, or maybe you just introduced a new bit of flakiness? It's very, very difficult to notice new flakiness being introduced when you're not completely 100% green. Once you are, it's kind of okay, right? It's still hard work, but it's getting there requires really significant investment, and it's not easy. But you kind of have to do it, right? Because in the modern world, every company is a software company. And the software companies that have this nailed will win, and everybody else will die, right? Maybe not tomorrow, but soon enough. So this is existential, right? This is why the likes of Google and Facebook and all the really dominant software companies, they're living up here in this really incredible productivity world. They can do stuff at such a rate, and if the rest of us can't get up here, then it's curtains, right? So how do you do that, right? It really does take a lot of effort to get there. Brute force is not going to do it. Those kind of reliability numbers that we looked at just now, you can't brute force your way to that. First thing you need to do is get rid of the flaky tests, right? Any test that is flaky, that is not 100% solid and reliable, is of negative value, and they compound quite quickly to produce something negative value. So you've got to get rid of them. But again, coming back to those really high reliability numbers that you need, you're very going to quickly end up with no tests, right? If you're not really getting to, if you're just excluding everything that's not totally 100%, you're going to quickly get down to no tests left. And this is a very, very common thing, right? People have a growing backlog, an ever-growing backlog of failing tests, of tests that fail, and no one knows why. And they are often, you don't know whether they're in the tests itself or in the product, but it doesn't kind of matter at this level, right? You just got these not understood, occasional intermittent failures. And it means at best you're going to be here or here. You can't ever get to there. So that's kind of why it's important. I'm going to give a real life case study now with SAP. This is the SAP HANA group, right? So HANA is the database that sits at the heart of SAP, and it's incredibly complex code. It's millions of lines of highly optimized C++, and it has very, very high reliability requirements, right? When HANA goes down, this means that like Walmart can't process any payments all afternoon or something. And they had, they invest a lot, right? They're a company that needs to be at the top right hand of that quadrant. They invest a lot in just having an enormous battery of tests, a lot of randomization and fuzz testing to try and find these edge cases. But it means that finding those 1 in a million flaky failures is really hard for them, right? So that's when they used the flight recording, and this is the stuff that they worked with us to provide this recording. It's flight recording or CCTV, whatever metaphor you want to use. And the idea is you record the execution of the program, and then you've got that recording, and you can view it later, and you can move anywhere in that recording. And this is an instruction level granularity recording. So this means that when you're trying to investigate that issue, you can wind the tape back and forth to any instruction that executed, and you can see any location in memory for any point in time, right? So there's nothing about the program execution that you now cannot just know. And you just need to capture it once. If it fails one run in 1,000, okay, it might take you a while, but once you've captured it once, you have everything that you need. So let's show what this looks like, actually, because I've got a little bit longer than was I thought. I'm going to switch to a real demo, just because they're always more fun, aren't they? But here's a slide where a demo of what this looks like to the developer. So I've got a recording in the debugger. Let me do it now. I'm going to show this for real. I'm going to load up the recording, and we're going to run it to the end, and my program has crashed, right? I mean, this is cert 0, and now I need to know like what happened, right? So investigating any of these failures, the question is always a repeat of these questions of what just happened, how did I get here? What I can do here is hit this uncall button, which is going to call up the call stack. Now, you might have noticed I'm deep in the C library, so there's no, this is the system C library, so there's no like symbolic information. That's fine. We've got a recording, an instruction level recording of what the program has done. I'm going to pop up the call stack into my own code, and now I'm going to start to rewind. I'm going to step this back in time, so I no longer have to guess where I've been from. I can come to here and I can see that, okay, so cache calculate is being passed number and it's returning square root cache. So it's supposed to return the square root of number. I can see here number was 255 and what got returned was 0. So cache calculate has returned the wrong thing. And I need to know why, right? Now normally there's a lot of trial and error, a lot of guesswork, but I can just step into cache calculate and find out what's going on. Okay, it's returning from the cache. It's returning the ith entry in the cache. I here is 34. So let's have a look at what that tells me. Okay, sure enough, the 34th entry in the cache contains bad data. Right, it tells me the square root of 255 is 0. So I've got no idea how that happened. Right, all I know is I've got bad data. This is a classic data corruption problem. Is it a logic error? Is it a threading problem? Is it a pointer error? We don't know. I'm going to add a watch point to that value there, so that I can then hit this button here, which is reverse continue. So watch point is a sort of thing that developers will be used to in a debugger, where you can run forward until the data changes. I'm going to run backwards until the data changes. Right, so that's going to be the line of code that caused the problem. So I'm going to hit this reverse button here. Gosh, and I've gone back in time, sort of staying vaguely with our Austin Powers theme, I've gone back in time to when the data was good. The square root of 137 really is 11 if you're using integers. And I can actually step forwards a bit here. So this is like watching sort of action replay, watching Match the Day or something. So as I step, if you watch that data in the bottom right there, step, step. So that's it. That's the corruption happening that's right there. So now I have to figure out, well, why did that happen? Well, we're writing number adjacent and square root adjacent into the cache. And I can see here number adjacent is -1. And so square root adjacent is garbage because you can't take the square root of -1. Well, why has that happened? Why have we taken the square root of -1? Well, now at this point, actually, it's reasonably easy to do that with code inspection. But as this is a demo, let's put another watch point on that and run back. I'll hit my first watch point. Okay, so I'm setting number adjacent to number -1, and number is 0. Okay, so here's my bug. I called cache calculate with the value of 0. It returned the right result. It returned 0, but it left, because it tried to work out one entry either side, it left one entry in a bad state, and I didn't notice for some time later. Right. So that's a very simple demo of how this ability to go over the tape and see exactly what happened allows us to very quickly resolve some of those really nasty, intermittent, flaky issues. So that I'm going to go over the slides. So actually, before I get back into SAP, I'm just going to go back. So, okay, maybe I'm not. I'll do that at the end. All right, so SAP deployed live recorder inside that really complex test environment, and they're running it all the time, and they're putting the database under enormous load, all kinds of fuzzing tests and everything, and when they get those very rare failures, they've got a recording. And then they can give that recording to the developers to look at. And even if they can't look at it this week, they can look at it next week or when they do get time, because that recording is there for as long as you need it. So here's some of the examples of the issues the intermittent issues they managed to capture with this, right? So a bunch of memory leaks and memory corruption, right? This is very powerful for this kind of thing, very difficult to track down. Once you've got that instruction level recording, you can just go straight to the source of the problem. A lot of issues in the networking code, right? So these are kind of timing dependent things and asynchronous things. Again, they're often the causes of these intermittent fails one time in 100 type problems. They had a lot of it using shared memory, shared data structures, and there were a lot of very subtle, sporadic problems with badly managed parallel access. And this is my favorite one at the end. An issue in the database, which was a race condition. This is the one. The race condition at the end, which meant that sometimes, like one time in a bazillion, the wrong row of the database would be returned. Right? And this is the sort of thing that actually, even in production, you probably wouldn't notice 99 times out of 100. You just go, oh, that's weird, refresh, okay, that's better. But one time in 100, you'd notice, hang on a minute, that's somebody else's bank account details or medical records or something. And then you might decide to do something bad with that, right? So this is really, really serious issues that lie in those intermittent failing tests. So you've got this tension, right? You need the test suite to be totally reliable, but you can't just exclude all your flaky tests because they contain, lurking in those flaky tests, are these kind of security breaches or production outages, right? And you can't brute force it unless you've got the scale of Google, so you have to use technology, and this is one of the things one of the ways you can do it. One other just demo I want to show, if I can get this to behave itself, because here we go. So inside Jenkins here, we've got this all set up inside a Jenkins server. So on these failing tests, we've got it to generate recordings. So usually, this is obviously very simple Jenkins setup, but usually in Jenkins you've got your artifacts, and typically you'll have log files, core files, something like that. Here we have undo recording files, and I can actually launch here straight into the debugger. Now this isn't going to render very well because the resolution's quite low, but hopefully you can see roughly what's going on, and it's kind of the same as what we saw before. We do have all the asynchronous non-deterministic events that have gone into this program on the left here that we can navigate through, and this is the same program, so I can continue it and do what we did last time. This is less visual, but you can see how FITS is more tightly integrated with the Jenkins workflow. So that was it. I raced through it a bit. I thought I might take a little bit longer, but I think that does give us a bit of time, 5 minutes or so for Q&A.
Is that a test tool or a programmer's tool?
I mean, it's both. I mean, one of the things I didn't touch on is it's really useful for the collaboration between test and between programmers, right? Because anybody, we've all been there of a test, somewhere in test the problem is reported back into dev, and dev say, works for me, right? Can't reproduce. Well, there's no excuses anymore. You can give them a recording, so you don't have to reproduce it. You can debug this. And so the way that environment that SAP are working in that I described as the real world case study behind this, that's exactly what they're doing, right? They have very complex test environment, and their testers are running this stuff, and they're handing these recordings over to developers, like in the Jenkins view there.
So can this tool be used more for like web-based application, or it can be used for like embedded products?
It can run on embedded. And we do have it running on sort of Raspberry Pi, for example. It does need Linux, so it can be like RTOS. And it's mostly, most of the use today is on sort of the bigger kind of enterprise workloads. So SAP I mentioned, IBM, Intel, Cadence, Synopsys, Mentor, MathWorks. Those are kind of that's the kind of usage where we see the most value, because there it's where you've got those millions of lines of code with very weird, very hard to track down failures that it's most valuable. But yeah, runs on Raspberry Pi just fine. Yeah, right. Well done for staying awake, everyone, anyway. Yeah.
Okay. Thank you, Greg. Well done.
Okay, thanks.